ladies and gentlemen, and welcome back to Agent West's Trailing Adventures. This time around, let's talk about logic. Let's start with a simple visual counter. As the time goes by, lights light up one after another. It doesn't really do anything, it just looks nice. And that's it. This one is really easy to make. All you need is an OR gate to be basically a toggle switch. Then from there, it goes to each light that you want to trigger. Each light has a small delay, so first one is quarter second, then half a second, then 3/4 second, 1 second, and so on. The delay can be anything, can be different from light to light. The point remains the same. As the time ticks by, the next light will light up, then the next, then the next. Let's say you don't want to rely on just one timer for the whole thing. Perhaps you want to trigger several things with each step of the sequence. So you use the OR gate as the trigger, and then AND gate for each step. And this is what you get. The connections of the system look something like this. The OR gate triggers the first step. After the first AND gate times out, it triggers the first light in this case, and the second step. Then second step runs through its timer, triggers whatever it should, and triggers a third step. Now the nice thing about this setup is that each AND gate has the same timer settings. The only thing different is what each gate controls. With the addition of some XOR gates, the ones on the right, you can get an interesting variation on that sequence, to where instead of all of the lights being lit up, only one at a time does. Connections in this sequence are as follows. The OR gate triggers an XOR gate. That XOR gate triggers the next AND gate and its corresponding XOR gate. The AND gate triggers its XOR gate, then an XOR above it, and the AND above it. The XOR triggers whatever it has to trigger, in this case a light. The tricky part is when you come to the top. The last AND gate triggers its own XOR gate to eventually trigger the light, as well as triggering the XOR gate at the very bottom. Now since we're talking about XOR gates, let's go back to the first example of a simple light sequence. With an addition of one XOR gate, this sequence can be modified to where one button simply runs the sequence as usual. However, with a second button, the sequence can be restarted at any time. In this case, the connections are as follows. The OR gate does nothing but trigger the XOR gate. The XOR gate is set to a different button and triggers the lights. That way, when the OR gate is triggered, the XOR lets the signal pass and lets the sequence run. However, as soon as a second button is pressed, the XOR gate shuts off, and therefore the sequence is restarted. The same idea can be used with an AND gate sequencer. With an addition of an XOR gate, you can restart the sequence at any time, without having to toggle the entire thing on and off. And that brings us to the first piece of logic, or as I like to call them, gates, the humble AND gate. The AND gate lets a signal pass only when both inputs are active. Trigger one, nothing happens. Trigger another input, nothing happens. Trigger both inputs, and we get an output signal. Next on the list is the OR gate. In other words, as long as either one or both, or just a second input are active, you will get an output. Last thing we have on the list is an XOR gate, sometimes called a XOR gate. With it, when you trigger one input, you get an output. When you trigger another input, you get an output. However, when both inputs are positive, there is no output. To finish off this little segment, I would like to point out that you don't have to have lights to show you which gates are on, which are off, which input does what. Each of the gates has little arrows on one of the sides. So in this case, it's an XOR gate powered by two OR gates. When one button is pressed, the first gate is triggered, and the XOR gate is triggered. You can see on the XOR gate that the left arrow, which points towards the symbol, is on, and the arrow that points away from the little symbol is on as well, which means that gate is producing an output. To make things more interesting, each of the gates has its own setup with different buttons for green and red, timers for delay before reacting to the input, seconds to stay active while receiving input, and time before the block resets its active time. as well as the output between red and green. By now you're probably asking, well, why does a logic has a green or red output? Well, if you think back, each motor, each hinge, anything that moves in Trailmakers can move in two directions, red or green. Same with the logic. For example, this orange hinge is triggered by two different logic blocks. The green one makes it go towards green. The red one makes it go towards the red direction. The connections in this case are as follows. The green OR gate goes to a hinge with a positive or green output. The red OR gate goes to the hinge with a negative output. When different sensors and logic gates are combined together, you can get some pretty interesting results. For example, the center module in this go-kart has a parking brake module which consists of two speed sensors on the top, two AND gates in the middle, a little motor, and an OR gate. The OR gate is triggered by a button, then signals from it go to the two AND gates. The signals from the two speed sensors, which one faces forward, one faces backwards, go through those AND gates and into the motor as a red and green outputs. When the system is active and the go-kart tries to move forward, let's say it rolls on a hillside, the little parking motor will try to push it back. But as soon as it starts rolling backwards, the other part of the circuit is triggered, and that little motor will try to push the go-kart forward. The result is something like this. Now this go-kart is fairly light, so when the system is activated it does tend to bounce back and forth a little bit. However, that effect is not noticeable with any heavier vehicle. Another interesting example of what can be done with logic blocks is this marker light set in the middle of this particular go-kart. While moving forward, a little red marker light is on, and while slowing down, a brake light comes on. Backing up, backup light is on. However, slowing down while backing up turns on the brake lights, just like in a regular car.